Okay, so now let's talk about RDS. So RDS is going to be small at the exam. We just need to know how many engines there are. So by now, hopefully you should know them. So there's PostgreSQL, MySQL, MariaDB, IBM DB2, Oracle, and Microsoft SQL Server. It's a managed database. You need to provision the servers though. You choose like the instance type, and then you get a bunch of things out of it: automated backups, patching, monitoring, and so on. You usually launch your RDS database in a VPC, in a private subnet, and then you control access to your database using security groups. And remember, when we have a Lambda function who wants to access our RDS database, we have to launch it into a private VPC subnet so that it has communication with our RDS database. The storage is on EBS volumes, and you can increase the volume size automatically thanks to autoscaling. For backups, you get automated with point-in-time recoveries, and the backups will expire. And the snapshots are very similar, but they're manual, in which case you can take a backup and have it in point of time for how many years you want. And it's possible for you to take these snapshots and copy them across regions, which is very helpful when you want to have disaster recovery. RDS also publishes a bunch of events to about what's happening to your database. So you can get an SNS topic that will contain all the events for your RDS. So it's called RDS event notifications. And this could be for operations, for outages, for when the backups are beginning, etc., etc. So here's another concept that you should know by now. There's multi-AZ, in which you have a standby instance for failover in case there's an outage. So we have a master RDS database and one availability zone, and it's going to be synchronously replicated to another standby instance in another AZ, so AZB. Your application only accesses your RDS database through one DNS name, and that DNS name will change automatically in case of a failover. And so that means that your standby database is never accessed by your application, only your master database is, and there will be reads and writes happening directly solely onto the master instance. So here, multi-AZ is really for recovery in case of outage. It's a backup database, it's a standby database, but our application never uses it. And if we wanted to scale the reads, then we would use read replicas. So these read replicas are going to be asynchronous replication, so we have eventual consistency, and they can be created cross-region, so it's possible to use replica to reduce the latencies in different regions in AWS. So your RDS instance will have an asynchronous replication into another RDS read replica, again, same region or different region. And then your application can do reads and writes into your main RDS database, but can also do reads only onto your read replica. This is why it's called a read replica. So once you have read replicas, you may want to actually distribute the reads of your application. And to remove some application logic, we're going to use route 53. So using route 53, what's going to happen is that you can create a weighted record set, okay? And in this example, I set the weight of every read replica endpoint to 25%. But we can set it to whatever we want. But if all your read replicas are having the same specifications, then it's a good idea to set the same weight. And we can also enable health checks within Amazon Route 53 so that if an RDS read replica is having issues, we don't include it in our record. And therefore, whenever an application is going to make a request to Route 53, and imagine we have 1,000 applications doing this, then each of them is going to be spread 25% on each replica. In terms of security, KMS encryption is available for your underlying EBS volumes and snapshots. You get transparent data encryption TDE for Oracle and SQL Server. You get SSL encryption to RDS for your database in-flight calls, and it's possible to enforce it. IAM authentication works for MySQL, PostgreSQL, and MariaDB. And authorization, even though you're authenticated with IAM, still happens within RDS, so you still need to define what your users can and cannot do inside of your RDS database. IAM cannot help you with that. You can create an encrypted RDS snapshot from an unencrypted RDS snapshot. So that means that you can encrypt an unencrypted database through the process of snapshotting. And CloudTrail, as a general reminder, cannot be used to track queries made within RDS. So if we do a deeper dive into RDS IAM authentication, it's available for MariaDB, MySQL, and PostgreSQL. And in case you use IAM authentication, you do not need a passport. You just get an authentication token that you obtain by using the RDS API calls. You should know that this token has a lifetime of 15 minutes, but it's only used to connect to your database, then you're good to go. If you want to reconnect, you would need to get a new authentication token. So how does that work? Well, for example, let's say we have an EC2 instance with the proper IAM role that allows us to get an auth token from the RDS service by doing an API call to AWS. Then using this auth token on an SSL encrypted connection, we can connect to the database. And of course, security groups must be properly configured. So the benefits of this is that you only get SSL encrypted traffic. Then you have IAM to centrally manage the users instead of managing them from within the database. And you can leverage IAM roles and EC2 instance profiles for a very easy integration. So next we have the RDS specificity for Oracle. And I wish you didn't have to learn them because it's quite boring, but you have to, and they can come up at the exam for 1 or 2 questions. So let's talk about backups. So you have 2 ways of backing up an Oracle database. You have RDS backups and then something else called Oracle RMAN. So RDS backups are used to backup and restore to Amazon RDS for Oracle, whereas Oracle RMAN, Recovery Manager, are to backup and restore to non-RDS. Okay, RDS is not supported. So a graph will help. RDS backups obviously must be backups of your RDS database instances, and then they can only be restored into an RDS database instance. Whereas, again, RMAN works for RDS database instance in terms of, yes, you can back it up, but then the restore only happens for an external Oracle database. It does not happen for an RDS database instance. So the flow is database instance, RDS database instance of Oracle to RDS backup to RDS database instance of Oracle, or RDS database instance of Oracle to RMAN backup to Amazon S3 to an external Oracle database that is living outside of RDS. Now, there's nothing called real applications cluster, so RAC. RDS for Oracle does not support RAC. It could be an exam trick. RAC can only be working on Oracle on EC2 instances because you have full control of Oracle when you set it up on an EC2 instance. Oracle does support TDE to encrypt data before it's written to storage, and DMS works on Oracle RDS, so you can do an Oracle database on premises that you want to replicate into the cloud. For this, you would just use DMS to replicate and migrate the data from the Oracle database on premises to the cloud. And there are some other exam tips you need to know for RDS for MySQL. So you can use the native MySQL dump tool to migrate a MySQL RDS database into a non-RDS MySQL database. For this external non-RDS database can be either on premises in your data center, or you can run it on your own, for example, on an Amazon EC2 instance. So you have the RDS MySQL database instance in your cloud, and then the target may be, for example, on premises, and simply you will use as a DB admin the MySQL dump tool to export it, import the data back into where you want it to go. Then you start a replication mechanism between the 2 databases to synchronize the data. And then once the replication is done, you stop it and you stop the source database. Another feature for RDS is the RDS proxy for AWS Lambda. So when you use Lambda functions with RDS, they actually open and maintain a database connection. And if you have many Lambda functions executing concurrently, you may happen to encounter a too many connections exception. So if you use RDS proxy, you no longer need code to handle cleaning up idle connections or managing connection pools, because all of this is done by the proxy itself. The RDS proxy supports IAM authentication or database authentication and autoscales. So you must make sure, though, that the Lambda function has connectivity to the proxy by either having a public proxy and a public Lambda, or a private proxy and a Lambda in a VPC. So a diagram will help you. So let's say we have Aurora database cluster in a private subnet. We create an RDS proxy in a public subnet, and our Lambda functions, which are operating publicly right now, can, through IAM, access the RDS proxy and therefore access the Aurora database cluster. Finally, one solution architecture we've already seen, which is how to do a cross-region failover with RDS, would be to check the database health either using a instance, for example, that has a /healthdb route to check, or a CloudWatch alarm. These things would be checked by a route 53 health check that would be linked to a CloudWatch alarm, and that would trigger a CloudWatch event. And this CloudWatch event would trigger a Lambda function whose role would be to update a route 53 DNS for the database and also promote a read replica that is maybe in another region. For example, US West 2, we have a cross-region replication in this instance, and then we have effectively created a cross-region failover architecture. So this is something very common that you should know for RDS, but we already seen this in details. And that's it. RDS really is a high level knowledge you need to know for the exam, but you should know enough by now. So that's it, and I will see you in the next lecture.